Exponential functions. So this is review from Algebra 1, and we did some in Algebra 2. Chapter 2 felt like it took forever. So we are going to talk about exponential functions and then logistic functions, which you guys, that is new, but they're kind of fun over the course of the next week or so. Going into break, typically what I like to do for this is because I like to quiz right before we go into our break, but it probably will be some sort of a group situation, just to give you heads up on that. So you will have one more little assessment before we go to break. An exponential function is really quite different than polynomials because we're dealing with an x, but the x has to be in the exponent. And so today, one of the questions I'll ask you is a function exponential or not? And in order for that to be true, the x would have to be in the exponent, okay? We end up having a lot of different bases, including, we'll see a lot more in pre-calculus than maybe last year, the base of e as an e to the x. Does anyone remember what this value gives you? You can turn and talk to your neighbor if you would like. All right. A is going to be the initial value, also known as the y-intercept. So when we're graphing these, which we will in a minute, that's going to be our point or an ordered pair on the y-axis. Our b value is what I like to refer to as the multiplier. And so exponential functions revolve around the fact that we're having repeated multiplication. So we're repeatedly multiplying by the same thing over and over. Like maybe I'll multiply by 2 over and over. That would be a 2. Maybe I'd multiply by 1/2 over and over. Then this would be a 1/2. So it's the multiplier. Exponential functions, then, we kind of have two main types that we refer to as growth or decay. Just kind of give me an indicator if you remember those words. Just give me a thumbs up if you remember growth and decay. So a growth curve is going to cross at 0b, and it's going to then increase pretty steeply. And it's going to, in the left direction, going to go towards 0. It'll never, ever, ever cross 0. We call this a horizontal asymptote. This is a growth situation. A decay situation starts really high and then comes down through that y-intercept, and this time approaches that horizontal asymptote as it moves to the right. So this would be a decay situation. All right, when we're dealing with growth and decay, it has to do with the value of the multiplier. Okay, so as long as x is a positive number, because when we make it a negative, do you remember what a negative exponent does? Oh, nobody remembers. A negative exponent flips the fraction. Yeah, it would flip b around. Okay, so that's why we have to make sure, as long as x is like a positive, it's a positive x up there. If this b is bigger than 1, what happens when you multiply by something bigger than 1? Is it going to grow or a decay situation? Growth. Okay, so as long as x is positive, is b is greater than 1, that's going to be a growth situation. And then if b is between 0 and 1, it's going to be decay. So really make sure we're looking at those b values when we're deciding if it's growth and decay. All right, so let's do, first of all, I'll kind of want to just make sure we know how to evaluate some, and then let's do some sketching of graphs. Suppose I gave you the function f of x equals 3 times 5 to the x. What I would like you to be able to do is to do some of these without a calculator within reason, okay? Meaning I'd rather have it be an unsimplified answer and you know what you're doing than just plugging things in a calculator and you don't know what you're doing. Let's evaluate these. What I would like us to do is just address a positive exponent, a negative exponent, and a fraction exponent so you remember what those do. So we're going to evaluate when, first we'll evaluate for x equals 2. Let's leave some space. Then we're going to do x equals negative 2. And then we're going to do x equals 1/2, just so we know what those things do to the function. All right, so for x equals 2, what I would just say is we plug the 2 in here. That would be 3 times 5 squared. What's 5 squared? So 3 times 25, so 75. Okay. This one, honestly, if you need to use a calculator because you're forgetting, that's fine. But I think all of us in pre-calculus can do 3 times 25. We just, sometimes we get too reliant on our calculators. All right, what would I expect around something like this? I would want you to write this as a fraction. Okay, so when I plug this in, I really care about this part, that you're not using a calculator for this. What's 5 to the negative second mean? How do I rewrite that? Earlier on, Carson said take the reciprocal. So the negative second means this is 1 over 5 to the second. So that's how we would rewrite that. And that's 3 over then 25. Is that making sense? Okay. All right. The last thing I want to address today is a fraction exponent. And I think we did a really solid job last year. By we, I mean collectively, you as a group. If I put this in, we are going to just rewrite it as a radical. And if we can't simplify it, we're going to leave it, okay? A 1/2 exponent means a square root. A 1/3 exponent would mean a cubed root and vice versa. So this literally means 3 times the square root of 5. Do I know the square root of 5? I do not. So then you could just leave it. Let's say it was the square root of 9. Well, then we could simplify it, right? But just understanding that you know what those things are, okay? 3 times the square root of 5, and then I just leave it. All right, so hopefully you remember those types of exponents. Let's move on to equations. Okay, what I'm going to give you is a table, and what we're going to do is write an equation for both f and g. And you're like, what are f and g? Well, I'm going to give you that. Would you draw a table? And in your table, I want it to have 3 columns, an x, an f of x, and a g of x. And then we're going to have our table have 5 rows for -2, -1, 0, 1, and 2. So go ahead and make your table. Suppose I told you that f of x was 4 over 9 in the top row, and then it went to 4 over 3, and then it went to 4, and then it went to 12, and then it went to 36. would you turn and talk with your neighbor? Would you identify the y-intercept and the multiplier, please? I'm hearing a lot of great conversation. To find the y-intercept, you want to find the y value when x is 0. The y-intercept is 4. Is that what you were getting? It might have been hard to tell the multiplier at first, but the multiplier is 3. If you multiplied 4/9 times 3, you could see hopefully that 3 goes into 9. 3 goes into 9 3 times, so then that reduces each time. You can really start to see it up here. Okay, so what's our equation for f then? It would be 4 times 3 to the x. 4 times 3 to the x. By the way, is that growth or decay? That's a growth. Okay. All right. For g of x, let's write a different equation. Let's have 175 followed by 35 followed by 7 followed by 7/5 followed by 7/25. Okay, if you would turn and talk to your neighbor this time, can you identify what you think is the y-intercept and multiplier? Okay, so y-intercept is 7. What about the multiplier? Okay, one way of writing it is 0.2, good. Some people will say it's 5 because they see these are being divided by 5. Remember, you have to write it as multiplication though. So dividing by 5 is the same thing as multiplying by 1/5, or as Carson said, you can write it as 0.2. So the equation for this one, for g of x, would be 7 times, I'll write it as 1/5 to the x power. Let's say you can't see this. I will give you a little tip. At any point, you can take, if you need to find the multiplier, you can take a y value, let's say y2, and divide it by its previous y value. So in the table, if we took 35 divided by 175, that's 0.2. You can at any point do that to find the multiplier. That would have worked on these as well. You take a y value and divide by its previous y value. All right, good. The very last thing I want to touch on then are sketches of graphs. And I want to be real clear, these are sketches, but I don't really want you using Decimus at this point. I want you to just use your brain, but they're sketches. So I don't expect like 15 points or anything like that. So what you're going to see on your assignment today is I'm going to ask you to graph a function and then a function with transformations. So we're going to graph y equals 2 to the x and also y equals 2 to the x plus 1 minus 5. Okay. So to do these graphs, because we're not using a calculator, we need to know how these two are related transformation-wise. So if you would turn and talk to your neighbor, what you think those two transformations with relation to that mean. All right, I'm hearing great conversation. So remember, x is a liar. So if it's x plus 1, this is you're gonna see it today really high where the x is. This is a right-left situation, and since x lies, this is actually a left 1. And I think most people got the down 5. So what would I be looking for on my sketch then? What I would be looking for on my sketch is that you simply took your original function and did those two things to it. So let's graph 2 to the x. 2 to the x is really 1 times 2 to the x, so its y-intercept crosses at 1 and it doubles. Let's just graph a point or two. Let's just graph 2 points and realize it's a curve. No drawing lines today, guys. You guys are in pre-calculus. We know this is a curve. So this is 0, 1. What if I multiplied by 2? What would I get? 2, the next one will be 4, the next one will be 8, and so on. But we're just going to do 2 key points. So we're going to do 0, 1. And if I plugged 1 in, that would go to 2. This is the original curve. That's all I expect for your graph. How would I move it left 1 and down 5? You'd literally take your 2 points and move them left 1, down 5. If you move this point left 1, down 5, where would it go? Left 1, down 5 would go to -1, right? And down 1, 2, 3, 4, 5 goes way down here. It would go to -1, -4. What if I moved the point 1, 2 left 1, down 5? That would go here and down 5, 2, 3, 4, 5, would go to 0, -3, and then you're just literally resketching your new curve. So this had a horizontal asymptote of 0, but now the new one would have a horizontal asymptote of -5. Okay. Use Decimus or graphing calculator after you're done just to make sure your sketch looks right. But just 2 key points is all I'm looking for. Okay, it doesn't have to be ridiculous. You don't have to table them or anything like that. Okay, that's all we got.